Hey, anybody have any questions as we get started? I handed out some packets last time, or a couple times ago, of paper clips. Did anybody take the opportunity to study all these different paper clips and figure out what was important? Which are the better types of paper clips? To me, looking at this stuff, you have a big one and you have little ones of this. You have big, what's called a gem paper clip, because it was invented or patented by the Gem Paperclip Company of Pittsburgh about 100 years ago. There's a big one, there's small ones that are coated. But there are some in here that, in my opinion, are definitely inferior. Did anyone figure out what those are? The smaller ones, I'm sorry, I might have. Small and flimsy, but what type of material are they made out of? Plastic, right? Why are plastic clips such lousy things? I mean, if you want a clamping force to hold the paper together, right? And you can get a bigger clamping force with a bigger clip, okay? I personally don't like small gem clips. I like sort of intermediate size because I get more clamping force. But and all these other clips were basically made out of steel rather than aluminum or copper. Why didn't anybody make them out of aluminum or copper? Well, A, they don't have enough stiffness because their Young's modulus is 1/3 that of steel. And B, those materials are too expensive. I mean, you can get stainless steel paper clips, but they're pretty pricey and they're hard to find because most people don't, you can chrome plate a regular steel clip and it works as well as, because you're not throwing it in water in most cases, okay? The paper tends to get soggy. But there were in here three different plastic clips. Actually, this is a composite clip. It's plastic, but it's got a steel spring. Okay, so it actually has a reasonable amount of stiffness. Okay, in part because it's heavier, more material, and you get the stiffness from the geometry, not from the modulus of the metal or the plastic. Anybody have an idea what the typical modulus of most plastics is? Well, you can give it to me in gigapascals, or I know it better in PSI, but it's about 2, basically 2 million, okay, as opposed to 30 million for steel. It's 15 times less stiff. So you're going to have a lot of geometry to give you there's 2 ways to get stiffness. You can either do it with the basic modulus of the material, which is the strength of the chemical bonds, or you can do it with geometry. You can make a bigger beam and it will be stiffer. And this particular one. I guess we can put it on there. You can probably see it. That one is not too bad, but it's still not quite as good. And I gave you paper, so you could have slipped a number of pieces of paper in there and then kind of pulled on it and see how tightly it's stuck. But these types of things, I mean, you've seen these paper clips, these plastic clips before. They're worthless. Okay? You pick up a sheaf of papers and they all fall apart because the clip can't hold them. Right? So why anyone would why would someone make a plastic paper clip? They're actually not as cheap as the steel. Okay? I think it's because you can get them in different colors. There's lots of reasons. I mean, the steel, they made this little smiley face. They punched holes in it and made it orange, okay? That has no functionality. It's basically aesthetics. But anyway, you could go through it. There was this one, which is sort of like one of these clamps, but it has no levers to open it. And I mentioned that you really had to have something else in order to grab it. And it turns out you have to have one of these, okay, which is pretty expensive. Although, did anybody read the little article on paper clips that was put on Stellar? About apparently 3 out of every 10 paper clips is never used, it's just lost. fell on the floor somewhere. You know, like when I came in here the other day, there was a paper clip on the floor. But this thing basically is you push this thing, slides it up, it opens it, and I could shoot it at you. Okay, so far as that goes. One of the problems with this, it has a good clamping force. It's made out of steel, but you have to have just the right number of pages to clip something together. But anyway, so the point is, even something as simple as a paper clip, there are thousands of designs. Many of the designs have no great functionality. You know that some of them are sort of standard designs, and there's a reason why they're sort of standard designs. Okay, steel is the material of choice. What choices do you have for something that has a higher Young's modulus? If you look at all the metals out there or other materials, which materials have the highest Young's modulus? Anybody, or something higher than steel? Anybody know? Anything? Diamond. Actually, that's the best. Has the highest modulus. It's a little bit harder to form it into a clip, but and it also could be a little pricey. But it has the highest, stiffest modulus by how much more than steel? Factor of 2. Say 2. Okay. 2. Yes, very good. Tungsten is almost as good as diamond. It's about a factor of 2. Molybdenum is also about 60 million. It's about a factor of 2. There's not a lot in between steel and those three. There are some ceramics that, I guess you can consider a diamond ceramic, that are up there in the 60 million. But there's nothing any stronger. Diamond's the strongest chemical bonds. And in fact, does anyone know how the chemical bond relates to the stiffness? You didn't learn this in freshman chemistry? See, they don't teach anything. You might have, okay. Well, you might have, okay. You ever heard of the, what do they call it? The Leonard-Jones potential, or basically the force of attraction between atoms, or the energy of attraction. So if I have an atom right here and I bring another atom up close, there will be an equilibrium, a minimum energy, and that's the equilibrium distance of separation. So this is the radius from here to another atom that's brought in, and it will go to the energy minimum. This is the attractive energy, 1 over r squared. This is the repulsive energy, which is the nuclear repulsion. No, this is the nuclear repulsion. This is the attractive 1 over r squared. And you get a net energy, and you have an equilibrium distance of separation. If you differentiate energy with respect to distance, what do you get? Force. Very good. That's freshman physics, right? Okay, if you differentiate the force with respect to distance, take the second derivative of energy with respect to distance, what do you get? Stiffness, or Young's modulus. Now, what is that in mathematical terms? What part of the shape of this energy function is that? It's the curvature. Okay? The second derivative is the curvature of the line, or the curve. So the stiffer something is, the sharper the Leonard-Jones potential, and the greater the stiffness. So if I had something in here, it acts like a little spring. You can think of it as 1/2 kx squared. If you think of force, or energy is 1/2 kx squared. A spring is minus kx for an elastic spring. So a little atom vibrating down in here, the stiffer it is, the sharper the Leonard-Jones potential. It's all chemical bonds between things. And it turns out there's nothing better than diamond. It's only a factor of 2 better than steel. And that happens to be one of the reasons that steel is so widely used. Aside from the fact that it's cheap, it has very good stiffness. It's one of the best, within a factor of 2 of the very best on the periodic table. Okay, just trying to bring some structural materials into this structural materials course. Anybody have any questions about anything? So kind of my summary from the last time is, Science seeks to increase the human condition, science seeks to increase human knowledge, and engineering seeks to improve the human condition. And in fact, if you were to go back to the various definitions we've had of science and engineering, you'll find usually the engineers somehow, in fact, on the first day when I asked you what's engineering, one of you said it's something that something about benefiting society. Okay? When you talk to a scientist likes to talk about increasing knowledge. And they say, and I've been listening to this all my professional career, that we need to do more science because doing more science will bring us great new things like the transistor. Well, it turns out there was some science, and the guys who won the Nobel Prize, Bardeen and Shockley, and No, it's Bardeen and Shockley at Bell Labs. There were three of them. Bardeen, Shockley, and Brattain. Yeah, okay. Bardeen, Shockley, and Brattain developed the transistor, but they were doing it because they wanted a highly reliable switch. Everybody says, oh, this came out of basic research. No, okay? It came out of the fact that in the old days, you see it on the old movies, you see the switchboard, and someone's putting these plugs into the, to make some operators making the connections. Well, then they got to the point where they had switches, and just down the street from me is a great big AT&T building. Not great big, it's the size of my house, but that's reasonable size. And it'd just be full of switches in the old days. Today, they could put it all on a little laptop, okay, to do all that same switching. But they developed, AT&T had done some studies, Bell Labs in the 1920s, on reliability of different things, like switches. And it turns out a switch might be good for 10,000 hours of operation, okay, flipping back and forth. Well, when you start getting to 10 million switches, that means you're going to have 1,000 failures an hour, okay? And so they were looking at the reliability of the whole network was just going to fall apart as they extrapolated into the future, and they needed a more reliable switch. And so they were actually trying to find an electronic switch, okay? That wasn't basic science. That was applying basic physics to an actual need, okay? So you always hear these things. Oh, well, science, studying basic science was what brought us the transistor. No, it was a specific need of society to have a bigger communication system that wasn't going to be constantly breaking down. And electronic switches were known to be about 1 million times more reliable than mechanical switches. But typically, to go back to where I was, the scientists tend to say, society should fund us because we're so smart and we want to study whatever we want, because if you do basic research and just learn more about anything, somehow there are going to be spin-offs and society will benefit. That is an absolute fallacy, okay? I just gave you the example of the transistor. Most things that have come about have actually come about because of a search for a human need. But this argument that the scientists make to Congress and the general public, we need to just study things for their own sake. So we spend $1 billion trying to prove gravity waves from space in the LIGO project. And it's really kind of neat. I mean, they're doing some great things, and they've improved surveying as a byproduct of it, sending someone to the moon, which actually was an engineering challenge, okay, more than a scientific challenge. You could calculate what size rocket you needed. You just had to then go out and build it, okay, which was sort of an engineering challenge. But there is this thing that the scientists think that they should be funded because they're so smart and everyone else will somehow benefit, but they can't tell you how they're going to benefit. And they really don't care if someone else benefits. But to talk a little bit more about science, one of my favorite quotes about science comes from Lord Kelvin. I actually have this mounted in my office. Professor Cohen had it mounted in his office. He was an institute professor from this department, and I TA'd for him when I was a graduate student. I often say that when you can measure what you're speaking about and express it in numbers, you know something about it. And when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science, whatever the matter may be. A scientist wants to discover new knowledge, and mathematics is the language of science. You've got to try to quantify it. And that's why scientists are typically very good mathematicians who can quantify things, and if they can't, they simplify the problem so they can. Because they're not really interested in solving a real problem, they want to create knowledge, okay? Whereas an engineer has different constraints. An engineer is going to be involved with complexity, ambiguity, uncertainty, and all kinds of other constraints on the system. When you're dealing in the real world, you're looking for a solution, you're looking for a good solution, and people often say we're looking for the optimal solution, but there is no such thing as an optimal solution. Design and synthesis of knowledge, there are no unique solutions for complex systems. It might be a better system, but it's not, there's no single unique optimum. In science, they like to define problems in a way where they can get some eigenvalue and they know this is the answer, okay? And if you think about it, you've been taught that all through your problem sets, okay? We give you problem sets where there's one correct answer, okay? Has anyone ever thought about why they do that? I've already told you they give you just the right amount of information and you just kind of manipulate it and don't leave anything out, don't put anything extra in, and you can make it, crank it, and you get a single number, right?
Yeah. Yep. Well, it's easy to grade.
Exactly. Okay? That's why they do it. I mean, if I'm grading a thermo quiz, if I have specific numbers and I see that number, pop, I go in the next question, pop, 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 okay? If it's wrong, if I want to be nice to the student and find out where they got it wrong, actually when you're grading, you find many students will make the same mistake. Okay, they use the gas constant in one set of units rather than another set of units, and they'll get the same incorrect numbers because they had the same incorrect input. But it's a determinate problem. Okay, if you put in the right numbers, you can turn the crank, and mathematics will give you the same answer. It's much harder to grade an essay question. In fact, it's almost impossible because I can't read your writing. And then if I try to understand what you're saying, it's even worse. And so I understand why the engineers and the scientists give you nice, closed-formed answers. It's much harder for the faculty in humanities and the social sciences because they give you quizzes. They give you a quiz that's actually trying to find out what you think. Okay, and it's painful to grade those essays. Okay, I have to do it in the sense of a student gives me a thesis to evaluate, and I have to read and try to figure out what it is they're really saying. So if I consider, we've talked about the hierarchy of snobbery, that I call it. Okay, if you talk about scientists, engineers, and medical professionals, clinicians sometimes people call them. A scientist, the goal is to increase human knowledge. An engineer to improve the human condition, and a medical doctor to improve human health. Their mantra is, well, the scientist just wants to do something. They want to do something, discover something new. They don't really care if it has an application. I mean, take the definitions. Listen to what the scientists say. Are they saying I need to do this it's going to solve, if they're saying that they're doing this to improve the human condition, they're probably doing engineering, okay, or medicine, but they're not doing real science. The basic scientists, the people who are studying the Big Bang Theory, okay, are the people who are trying to understand what's going on in outer space. it's not clear that that's going to really help the people who are starving in Bangladesh, okay? The engineer is trying to do good. The medical doctor is trying to do no harm. That's their mantra. But in fact, they're trying to do good. But the old Hippocratic oath is do no harm. How the scientists will study anything, because anything is good, is good. Everything's fair game for the scientists for studying. The engineer, if you remember von Karman, creates something that never was. So the engineer is trying to create something, and that thing is probably going to be something that's useful. Okay? In fact, engineers look down on people that are doing things, just like I'm looking down on it right now, the scientists who are doing useless things, because to the engineer, the ultimate thing is to do something useful. Okay? And same thing for the medical clinician. They're going to administer the sick and also nowadays to the healthy to keep them from getting sick. But the service for the engineer and the medical doctor is to society. The service, it's not clear who the service is to for the scientist. They just want society to provide them with the resources for them to go out in their sandbox and do what they want to do. I mean, just, I may be saying it pretty strongly, but that's what I've been listening to for many, many years. And that's the argument. So when you hear these arguments, you can tell if the person is really a scientist or if they're really an engineer or a medical person, depending on who they're trying to help. And that gets down, I gave you this article out of the faculty newsletter on the very first day of class on leadership, management, and education at MIT. At the time, I just spent 15 years working with people over at the Sloan School of Management. I had some good friends who rose to the top of Harvard Business School. And it used to bother me. Remember the last slide I put up the last time I lectured was a comparison between the starting salaries and the decision-making responsibilities of an engineer versus a manager. If you go to get an MBA, okay, you're going to make 50, 60% more as a starting salary. You'll have managerial decision authority, whereas the engineer is just sort of a technician, okay, that makes less money. And that's a problem for engineers. And I came up in this paper with a short synopsis of the leader seeks to help others, a manager seeks to control others. And in fact, if you start thinking about, well, you can watch someone's style, because some people who are the boss are actually leaders, and some people are control people, okay? They want to micromanage, they want to be the boss, they want to, we're going to go through that in a second. The basic problem that I have with business schools is they teach management and not leadership, okay? We need more leadership in the world. We don't need more management, okay? Particularly, well, I take that back. There's actually two groups of people, and this is sort of, and one of the problems is I live in this little shell called MIT, where everybody's pretty capable. I don't need managers at MIT. I need leaders, okay? You're capable of doing things yourself. If I just leave you alone, you'll do a better job than if I manage you, okay? Because the MIT students are a select elite group. If you get out there in the real world, you're going to find a lot of people just don't have any motivation. And you have to have someone to kind of kick them to get them to do things. And there's two types of, in that case, there's two types of leadership. One is what I call Confucianism, which is a set of rules. And typically the way they run the unions, they have certain sets of rules that the management sets up, and they negotiate with the union, and everybody lives by the rule, lives and dies by the rules. And that's what Confucius taught. He had a bunch of rules, and that was how you're supposed to live your life. Then the Taoism, okay, Taoism, you remember yin-yang, go with the flow, okay? Taoism is the opposite of Confucianism. There's no rule that can't be broken in Taoism, okay? You kind of let however the spirit moves you at the moment, okay? Go with the flow. And in fact, MIT used to be that way when I was a student. You basically could, there were all kinds of rules, but you could get out of any rule at MIT when I was a student if you had a good reason. There were actually people that would listen to you, okay? But what's happened, in my opinion, over the last 30, 35 years, as MIT got to be a bigger and bigger business, when we passed the $1 billion mark in annual budget, they started hiring more and more managers who want to set up rules, who want to control people, and it doesn't have the flexibility or the ability to be creative that we used to have. Now you're supposed to be a conformist, okay? So here I'm going to go through basically what's in that article that I gave you the first day about leaders versus managers, and this comes from an address that a guy named Hugh Nibley gave at a commencement at a university in the early 1980s. So it's called The Fatal Shift. From Leaders to Managers, The Fatal Shift. And he says it pretty strongly. I can't say it any better than he said it. Leaders are movers and shakers, original, inventive, unpredictable, imaginative, full of surprises that discomfort the enemy in war and the main office in peace. Okay? So this is the troublemaker. Okay? If you're at war, they're creating problems for the enemy by doing things differently. If you're at peace, they're creating problems for the administration. Okay? Managers are safe, conservative, predictable, conforming organization men and team players dedicated to the establishment. The leader, for example, has a passion for equality. We think of great generals from David and Alexander on down, sharing their beans or masa with their men, calling them by their first names, marching along with them in the heat, sleeping on the ground, and being first over the wall. Okay? Now I'll make a racist comment for those of you that come from Asia. Okay? Is the Asian culture management or leadership? How many Asian students want to call me by my first name? The Asian culture is such that the professor is somehow way above everyone else, right? I remember I had a brilliant student from India, and he was going home. He was a graduate student doing his doctoral thesis. He says, I'm going back to India. What do you want? And I said, what do you mean, what do I want? Well, it turns out the tradition for him in India and in many other parts of Asia is you ask your professor what they want, and whatever the professor says, you have to give them, even if you can't afford it, okay? And so as he explained this to me, because I kept on saying, what do you mean, what do I want? Because in my culture, it's actually almost a crime for the professor to extract something from the person beneath it, that they have supervisory authority over, right? But it's a sign of respect in Asia, but it's actually the opposite in the United States. It's actually abuse, okay? I remember my first student from Asia. He didn't like calling me by my first name. I said, just call me Tom. Who calls me doctor, okay? I'm not a medical doctor. I can't give you a prescription. I'm not a doctor. And that's the difference between his Western culture and Asian culture. But the Asian culture, there have been lots of studies. Why are Asian students, or why is Asian society not as creative? Well, they are as creative, but they've been trained to think in the Confucianism style of certain rules and doing things by the norm and being obedient. Whereas, boy, we teach disobedience in the Western culture, and you're seeing it now with terrorism and everything else, okay? It's kind of gone to an extreme. But in any case, it wasn't really a racist comment, but there are cultural differences that I continue to see. One of you didn't like calling me, or one of you was sort of insistent on calling me professor or something. In fact, well, I see it in the U.S. military. I teach the military officers in 2N during the summer. And they always call me sir, and I always turn around, who's he talking to? Okay? Because none of the MIT graduates would call me sir. Okay? And I wouldn't have called somebody sir when I was a student. Okay? It's a sign of respect, but there's more of a feeling of equality among the kind of Western culture than there is in the Asian culture, where it's a hierarchical society. In any case, Nibley went on to talk about the German High Command, the General Stab, which after World War II tried desperately for 100 years, and going back to the 1880s, to train up a generation of leaders for the German army, but it never worked. Because the men who delighted their superiors, the managers, got the high commands, while the men who delighted the lower ranks, the leaders, got reprimands. And as I started to rise up in 1990 through the MIT administration, I saw this all the time. I could spot the person within minutes of whether they were a manager or a leader, okay? Were they trying to suck up to the people who were the bosses above them, or were they trying to help the people that they were put in charge of, okay? I see it among faculty supervisors of students, okay? Are they telling the students what to do and expecting obedience, and are they thinking for the students, okay? Or are they someone that says, okay, here's the laboratory, it's your sandbox, I want you to solve this problem, and letting them have the freedom to do it? Where do you think you get more creativity? The latter, because two heads are better than one, okay? And in fact, the advisor, faculty advisor, student mentorship, if it is a partnership, it is two heads, or five heads if you're part of a group, okay, thinking together. But if it's just, I remember, there's a faculty member who's passed away now in this department. He would sit down every week with his graduate students, and he would go over their lab notebook every week. It took a lot of time, and the graduate students sort of feared going in to see him because he would start nitpicking at little things. And I mean, there was a story that he was even telling them to be, he was actually from Minnesota, and he was a wonderful man in many ways, but he had learned this sort of management way that it was his job to hand the knowledge down to the student. And the story was, the student went in, and he was telling them on thermocouples. You know what thermocouples are? You take two dissimilar metal wires, and you put them in one hot zone and one cold zone, and you get a voltage in between. You can measure the temperature. So he's telling them to, when your thermocouple breaks, cut it off very close to the tip where you made your little weld, so that you can re-weld it and things. And I thought he was talking about platinum and platinum rhodium thermocouples, because you're talking platinum wire, which can cost a few dollars an inch. He was talking about chromel alumel, which is stainless steel and nickel alloy, which costs pennies per inch. So, but that was his mentality, okay? You do everything by the book, and he would sit down and tell them what to do. When they were all done, who had learned how to do a doctoral thesis? Not the student, okay? This particular professor, I won't rub his name into the ground, because he was a very kind person in many ways, but he just thought his job was to tell people how to do things, because somehow he had more knowledge than anybody else. Well, is that a question, or are you just rubbing your hair? Okay. I learned in my very first week at MIT that I was in the bottom third of my entering class. So I always assumed that I'd let the students figure out how to do things, okay? I'd give them a problem, and in fact, I used to, for a doctoral student, to a certain extent with a master's student, but a doctoral student, I'd sit down with them, I'd say, okay, this is what we got the research contract for. This is the question that we have to answer, and the question could change over time. But this is right at that time. That was the question that we wanted to try to address. And these are some of my ideas of how I might go about it. But I want you to go out and come back and tell me how you want to do it. Well, some students would come back, a week later, and they say, well, I've thought about it and I want to do X, Y, Z. And we talk about it, and many times, most times, their idea was better than my idea. Okay? And then there were other students who were intimidated by that. In fact, I did that with my very first doctoral student, who happened to be from Taiwan, and he told me later he was scared to death. He had come in to have me tell him exactly what he was supposed to do. okay? And I didn't realize, my culture was, hey, Chai, I want you to go out and I want you to this is the problem we got a contract for, and this is some of the things I do. He was scared to death. He went over and talked to another professor and told him he was frightened. Well, I learned that, be a little easier, recognize the culture they're coming from. But to tell you another story, one of my next students from Taiwan, Mark had done a master's thesis for me, and he'd done a good job on it. But with a master's student, I kind of gave him a little more guidance of what to do because they had to finish in about a year, right? The doctoral student is all open-ended, and so he came to me after his master's thesis and said, well, what problem do you want me to solve? And I said, well, and I gave him a problem. And he came back 3 weeks later and said, Professor Eager. He still called me Professor Eager after a year and a half, right? Because he couldn't bring himself to call me Tom. That was his culture. And he comes in and he says, I've looked through every book in the library and I can't find the solution to the problem. I said, Mark, if there was a solution, you're doing a doctoral thesis. If there was a solution out there, I wouldn't have told you to solve that problem. You're supposed to be doing something new. And so we had a discussion about that. And he kind of learned, okay, and I gave him some ideas of how he might go about solving. He did an excellent doctoral thesis. And I used to have a habit of taking every doctoral student after they'd finished their exam, sometime during the next week, I'd take them over, usually Legal Seafood or somewhere, one-on-one, and we just kind of talk about things. Because no longer was I their supervisor, I was their colleague, right? They had a doctoral degree too. And I could then ask them how they would change things in the lab. And Mark had been working on a welding problem, which was a sort of a fluid flow problem. It was a complex problem, but he'd done an excellent job. And he had gotten this job to do finite element analysis of plastic injection molding, which had nothing to do with anything he had learned. And here was someone who, 2 years before, or 2.5 years before, thought that everything he was going to work on was found in a textbook, right? And I said, Mark, how did you get this job? He was going to RCA, they had a big lab, Sarnoff lab. And he was going to be doing viscoelastic flow of polymers and modeling of it by finite element analysis. We didn't do finite element in my lab at that time, okay? I mean, it was completely different. I said, Mark, how did you get that job? He says, well, you taught me I can do anything. And that was the best success story I can ever tell you, was he said he had learned that he could do anything, okay? And that's what you need to learn at MIT, is forget the professors, forget the institute. You have to learn that you can do anything by yourself. And when you do that, that's when you've really become a doctoral. You've earned your doctorate, okay? Because it doesn't matter what problem anyone ever gives you, you can go out and solve it. Okay, so Nibley goes on, for the manager, the idea of equality is repugnant, because before it said, it was talking about, oops. Oh, okay, well, I think I maybe have the right order. Manager, the idea of equality is repugnant and even counterproductive. When promotion, perks, privilege, and power are the name of the game, awe and reverence for rank is everything. The inspiration and motivation of all good men. Where would, he's a little sexist, this is 30-year-old language, okay. Where would management be without the inflexible paper processing, dress standards, attention to proper social, political, and religious affiliation, vigilant watch over the habits and attitudes that gratify the stockholders and satisfy security? So you'll see Nibley doesn't like managers. Managers do not promote individuals whose competence might threaten their own position. And so as the power of management spreads ever wider, the quality deteriorates, if that's possible. In short, while management shuns equality, it feeds on mediocrity. On the other hand, leadership is an escape from mediocrity, the leader being simply the one who sets the highest example. Okay. True leaders are inspiring because they are inspired, caught up in a higher purpose, devoid of personal ambition, idealistic, and incorruptible. Believe me, most managers I have found to be quite corruptible, okay? Money talks in many cases. Okay, so that's Nibley's take on managers versus leaders. I can tell you, I agree 100% with Nibley about the two types of people. And I could point to people, well, first of all, there's a basic asymmetry here. Who rises to the top? Managers. That's their goal, is to rise up the next level. When I was department head, I can't tell you how many times I came back from engineering council, where you have all the department heads and the deans, and I go into Joe Dosey, who is the administrative officer in the department. And when you're department head, there's not a lot of faculty you can talk to, frankly, about things, because you're the boss. No one wants to talk to the boss and tell them how they really think, okay? So I'd go into our administrative officer, who was actually a graduate of this department. He had a master's degree from the department, but he was basically the administrative officer. And he and I had very similar views. And I'd go in and I'd say, Joe, how come people are making decisions and doing things in trying to get their next job rather than doing the job they're in? Okay? And you will see that over and over. People will make decisions. The managers, the people who are trying to move up the corporate ladder, will make decisions trying to please their bosses, just like Nibley said, so that they get the next promotion, rather than trying to protect the people that they are supervising from all the quirks in the system that demotivate people. Okay? There's been lots of studies about people who don't do a good job at work. Okay? These might be union employees or whatever. But I've always said I don't know anyone who goes home at the end of the day saying, I'm glad I did a lousy job at work today. Okay? What they will say is, I've been trying to do my job, but my boss won't let me do it. Okay? So what do you do? How do you manage this process of dealing with your boss if your boss is a manager? Okay? Well, you have to go back to the question of, why did the company hire you? I'm asking at the most fundamental level, why will someone hire you? So I'm giving you some counseling on seeking a job and interviewing. Anybody know the answer? They hire you because they think you can help them solve their problems. They have this thing called money, but they have these problems, and they want to make more money, which is nothing wrong with that. But they have these problems, and they're willing to give you some of their money to help them solve some of their problems. And it's important to recognize that's why they hired you. They didn't hire you to hear you come in and whine about what the problems are. They asked you to come and solve the problems. So I always tell students that if you're whatever type of engineer you are, a materials engineer, mechanical, chemical engineer, and your boss gives you a problem to solve, and you find out it's an accounting problem, you better solve the accounting problem. Your boss is not going to give you the same problem you did your thesis on, with just the right amount of information, no more, no less, like the problem sets you got at the university. They're going to say, I got this problem, go solve it. And so the corollary to all that is, you never bring a problem to your boss, okay? You only bring solutions to your boss. You don't come in and whine and say, I can't do this because. I mean, I get this sometimes from some of the internship students, and I'm not very kind about it. I say, look, you've got to solve that problem, okay? Because they have to learn to solve some of their own problems. But how do you come into your boss? You've thought about it. You've determined that there are 2 or 3 possible solutions. You go in and say, okay, this is the problem we face, and I think there are these 2 or these 3 solutions. Which one do you want to pick? And if you're really smart, you've already decided which one you want to do, and you phrase it all so that only an idiot would pick anything other than the card you want to play, right? So, but you always give your boss a choice, particularly if they're a manager. But you phrase it in a way so only an idiot would pick something else. Now, there are some idiot managers out there, so they may pick the wrong one, but nonetheless, you tried, okay? Now, in all of this differentiation between leaders and managers, how can you tell? Let me hide part of this. Okay. How can you tell? How can you determine whether you want to work for a company before you even walk through the door? Now, if you read my article, you'll know the answer to this. No one remembers. Some of you probably read it, you just don't remember the answer. You look for the number of assigned spaces in the parking lot. Okay? I can't tell you how many times I've talked to people in industry and said this, and they agree with me. Immediately, they agree with me. Why? Because you can tell whether you're in the hierarchical management type of organization or whether you're in a group of leaders. Okay? And that was in my article, folks. So I remember there's a story, a heart cell propeller. I had a case where a propeller had failed, and I had to go out to Heart Cell somewhere in Ohio, wherever it is. And the president of Heart Cell was an MIT grad. And it turns out he got to work at 6 a.m. First one in the parking lot. There were no assigned spaces in the parking lot, okay? But he always parked in the one closest to the door because he was the first one in the parking lot at 6 a.m. Remember what Nibley said. The leader sets the example, right? He sets the highest example. So, but one time, he had to go to the bank or something, and he didn't get in until 10 o'clock. That space was waiting for him. But it wasn't waiting for him because people were afraid of him. It was waiting for him because they respected him. Okay? And if anyone who needs an assigned name on their parking space is admitting they do not have the respect of their employees. And they're not setting the highest example. Okay? Did I ever tell you about giving, when I became department head of the Christmas breakfast for the custodians? Did I ever tell you that story? I think we can do it in this amount of time. Okay. So when I became department, I get in about 6 a.m. and stuff. I used to get in earlier than that when I was fighting for tenure and stuff. But I finally got a parking space after 20 years right over here by Building 10 where the custodians would clock out between 6 and 7. These are the nighttime custodians. And if you actually read that article, same article in Leadership that I gave you, I say that the people that would be most recognized that they had quit working, who were they? Which I gave two groups at the university in many companies. The people who clean the restrooms and the people who fix the food. Okay? I mean, if a faculty member quit working, you couldn't tell for 5 years. Okay? Okay? There's no motion. Okay? It's like watching. Anyway, can't remember how the guy said it, but anyway. So anyway, I thought it was important to show some respect for these people, many of whom were out rushing to get out at 7 o'clock to go to their next 40-hour-a-week job. Okay? These people don't make a lot of money. It's not very highly paid. It's not particularly respected. Okay? In fact, they don't like to be called janitors. They like to be called, engineers or something, sanitary engineer, whatever. They get different types of names because society sort of looks down on them as a lower paid, something lower than the manager at the top. So anyway, when I became department head, I decided it would be a nice gesture, and Joe Dosey and I worked together. We had a shipment room up on the third floor and had a little kitchenette. And I would, once a year, right before Christmas, it's between 6 and 7, because I would get permission from the woman who ran physical plant, and she said, okay, she'd let them get off work at 6, and we would give them scrambled eggs and bacon and sausage and French toast, and we'd fix a breakfast for them and tell them that we appreciated all they did during the year. Well, first of all, one of the first things I learned is they cleaned up after themselves. At a faculty meeting, they're pigs, okay? They just leave their plates and everything all around for the department head and the secretaries to clean up, right? So first they were very appreciative and very respectful, but I later found that we got great service. We had the best service from physical plant of any department in the Institute. And all 1 hour a year, we actually showed respect to them, okay? That's all they needed was someone showing a little bit of gratitude, okay? And then when I stepped down as department head, I used to often get that best spot. For over a year, that space was saved for me, okay? And I know there were people saying, don't park there, that's for Professor Eager. And after about a couple of years, when I was no longer doing this as department head, they had new people and it kind of went away. I'll tell you another story on that respect. So I had a student working for, it was a small division of what was Honeywell. They had bought a little mom and pop operation that made plastic sheet, okay? And so in the LGO program, back then it was LFM, but you have to go and visit the site with the student. And so I had this woman graduate student, and we went down to New Jersey to visit this little facility that she was going to be working at for 7 months. And we found that the morale was terrible in this plant. Honeywell had bought it a couple of months before, but all the workmen had their toolboxes locked up, and if they left it unlocked, they'd have their tools stolen by some of their colleagues. The management and the engineers and the hourly union workers hated each other, despised each other, and there's also the problem of the mad shitter, okay? And that's what they called him, whoever he was. But some guy would go in the men's room, and he would take his excrement and he would smear it all over the walls. I'm sure he was wearing rubber gloves, probably. But nonetheless, and he'd do this anonymously because they'd probably beat him with a pulp if they found him. But that was this is what this young graduate student was going to walk into. So we learned all these things on our visit. And we could see the people weren't working very hard. The place was sort of sloppy and everything. And so on the way back to the airport, we stopped at Dunkin' Donuts or some diner or whatever. And I told her, well, what are you going to do about this? She said, I don't know. I said, I'll tell you what you're going to do. I'm going to give you the money to buy a dozen donuts or 2 dozen every Friday. And you're going to come in and you're going to put the donuts by the coffee machine. And within a week, they were coming up to her, putting their arm around her, showing her how the plant worked and everything, because she had showed respect for them by doing something for them. Within 2 weeks, she could go out and find out what the problems were. She could help solve the problem. She actually told them, I also said, you're going to tell them that you want to know what's bothering them and that you're going to do something. You can't fix everything at once, but you're going to take one of those problems that they tell you and you're going to fix it, okay? And it was her choice which one of the problems they told her to fix that was bothering her. She could pick the low-hanging fruit, okay? But she was going to fix the problem, okay? And she did. She brought in donuts, which showed, oh, here's someone that shows some respect to the people who work under them. And then she asked them what they thought, which also showed respect. And then she acted on it, okay? She turned the plant around. 1 leader, okay? Turned the plant around. Not completely, they still were losing money. But that was another problem, okay? The product was junk. Anyway, but at least, they no longer had a mad shitter, okay? People don't do something. I said to her, why do you think someone's doing that? And she wasn't, I don't know. I said, they're not doing it because they want to. They're doing that because they're completely frustrated. They don't know anything else to do. They've complained and no one hears. They need someone to listen to them. So bring them some donuts, listen to them, do something. And they don't expect you to solve all the problems tomorrow. Do something and you will be successful. And she was. It's just a matter of respecting other people. But managers, rank and privilege is everything. And managers want to get above everybody else. And I can tell you some people here who were department heads when I was department head. Now they're now presidents of universities. I'm glad that they're not at MIT, and I don't have to deal with them. And I feel sorry for the faculty at those other universities, because these are quintessential managers. Rank and privilege and perks are the #1 thing for them. So that's what you have to think about when you go out there in the real world. Okay, thanks.